The sun disappears, and in its place appears a black hole, the size of a city. Earth keeps orbiting, but life only has weeks left. Every second, the sun pours unimaginable energy onto our planet, powering weather, oceans, ecosystems, and life itself. But what if it suddenly vanished? What if it were replaced by something else? A massive blue star, a red giant, a neutron star, or even a black hole? Today, we're running one of the most extreme thought experiments in astronomy, swapping our sun with other objects in the universe and tracking what happens to Earth, step by step, until the final, terrifying outcome. Stay with me, because some of these replacements don't destroy Earth instantly. They make things far worse. Before we start swapping cosmic objects, we need to understand something fundamental. The sun does two critical jobs. First, gravity. Its mass keeps Earth and every planet locked in orbit. Second, energy. Light and heat from nuclear fusion inside the sun drive Earth's climate, photosynthesis, the water cycle, and almost every biological process. Astronomers at NASA and ESA emphasize that mass controls orbits, but energy controls habitability. That distinction is about to decide Earth's fate. Let's begin the experiment. Instantly, the sun collapses into a sphere only a few kilometers wide, its mass unchanged, but its surface gone. No explosion, no shock wave, just darkness. According to NASA's Goddard Space Flight Center, if the sun were magically replaced by a black hole of identical mass, Earth would keep orbiting exactly the same way. Gravity doesn't care whether the mass is a star or a singularity. It only cares how much mass is there. So, the planets survive. At first, but within 8 minutes, sunlight stops arriving. The sky goes black in the middle of day. Within days, global temperatures plunge below freezing. Within weeks, photosynthesis shuts down, plants die, food chains collapse. Oceans begin freezing from the surface downward. Only a few deep-sea ecosystems, powered by geothermal vents, might cling to survival. Earth doesn't fall into the black hole. It freezes into a wandering ice world. Now, let's go the opposite direction. Instead of shrinking, the sun becomes huge, a red giant, like Betelgeuse. These stars swell hundreds of millions of kilometers across near the end of their lives. Astronomers studying stellar evolution show that when our real sun eventually becomes a red giant in about 5 billion years, it will likely engulf Mercury and Venus, and possibly Earth. If one appeared instantly today, Earth would find itself inside the star's atmosphere. Temperatures reach thousands of degrees. The oceans boil away. The crust melts. The planet loses its atmosphere entirely. There's no slow freeze this time, just vaporization. Earth becomes a scorched core orbiting inside stellar fire. Now imagine replacing the sun with a brilliant blue giant dozens of times more massive and hundreds of thousands of times brighter. These stars burn hotter, faster, and flood space with ultraviolet radiation. At Earth's current distance, the surface temperature skyrockets. The atmosphere strips away. Radiation sterilizes the planet. And there's another problem: mass. If the new star were much heavier than the sun, Earth's orbit would shift inward, possibly becoming unstable or slingshot outward. And massive stars live fast and die young. After only a few million years, this star would go supernova. That explosion could blast Earth apart entirely, or at minimum strip away the atmosphere and oceans, leaving behind a barren rock. Now we downsize. Red dwarfs are the most common stars in the galaxy, small, cool, dim. If a red dwarf replaced our Sun at the same position, two things happen. First, less gravity. Earth's orbit expands. Some outer planets might drift away entirely. Second, far less light. Temperatures plunge. Glaciers spread from the poles to the equator. Oceans freeze. Earth enters a global ice age far beyond anything in its history. Ironically, planets around real red dwarfs could be habitable, but only if they orbit extremely close. At Earth's current distance, we freeze solid. This one is nightmare fuel. A neutron star packs more mass than the Sun into a sphere barely 20 kilometers wide. Gravity near its surface is so intense it warps space-time. Radiation beams blast outward as the star spins, creating a pulsar. If such an object appeared at the Sun's location, Earth stays in orbit, but deadly gamma rays and X-rays sweep through space. The ozone layer is stripped away. Radiation cooks the surface. Electronics fail. DNA shreds. Even underground life struggles to survive. The planet becomes a radioactive wasteland long before freezing sets in. Let's try something strange. What if the Sun were replaced by a giant planet like Jupiter? Jupiter has only 1,000th the Sun's mass. That means the gravitational grip collapses. Earth flies off in a straight line into interstellar space. Same for Mars. The asteroid belt disperses. The entire solar system dissolves. Without the Sun's mass anchoring it, our cosmic neighborhood unravels in hours. Earth becomes a rogue planet, drifting between stars. Frozen forever. By now, something terrifying is clear. Most swaps kill Earth. Fast. But here's the deeper question. Is there anything in the universe we could replace the Sun with and survive? What conditions actually make a star life-friendly? Let's break it down. Astrophysicists studying exoplanets using telescopes like Kepler and James Webb have identified a narrow zone around stars called the habitable zone. That's where liquid water can exist. To keep Earth alive, a replacement object must have nearly the same mass, emit roughly the same energy, shine steadily for billions of years, avoid deadly radiation, not explode anytime soon. That's an incredibly rare combination. Only Sun-like main sequence stars fit that profile. A slightly smaller yellow star? Maybe survivable. A slightly cooler orange star? Possibly. But drift too far in any direction. And Earth either burns, freezes, or flies into space. This explains why astronomers searching for life focus so intensely on Sun-like stars. Our star isn't dramatic. It isn't huge. It isn't flashy. It's stable. And stability is what makes civilization possible. Now let's push the experiment to its absolute limit. What if we replace the Sun with something truly extreme? A supermassive black hole, like the one at the center of the Milky Way. 4 million times the Sun's mass. Instantly, Earth's orbit collapses. The planet plunges inward at unimaginable speeds. Tidal forces stretch continents. Oceans lift into space. Mountains tear apart. Before Earth ever reaches the event horizon, it's ripped into a glowing stream of plasma spiraling into darkness. The solar system becomes an accretion disk. The night sky burns brighter than any star ever did. This is not freezing. This is not boiling. This is complete annihilation. So what happens when we swap the Sun? A black hole of equal mass? Earth survives, briefly, then freezes. A red giant? Vaporized. A massive blue star? Sterilized, then obliterated by a supernova. A red dwarf? Frozen solid. A neutron star. Radiation apocalypse? Jupiter. The solar system falls apart. A supermassive black hole? Total destruction. The lesson is unsettling. Our Sun is not special because it's powerful. It's special because it's perfectly ordinary. calm, stable, middle-aged, quiet enough to let oceans flow, forests grow, and civilizations rise. In a violent universe full of exploding stars, collapsing cores, and cosmic monsters, we are orbiting one of the safest furnaces nature ever built. And if you enjoyed the video, make sure to like and subscribe, and check out the channel to find more amazing and new videos. The sun disappears, and in its place appears a black hole, the size of a city. Earth keeps orbiting, but life only has weeks left. Every second, the sun pours unimaginable energy onto our planet, powering weather, oceans, ecosystems, and life itself. But what if it suddenly vanished? What if it were replaced by something else? A massive blue star, a red giant